Hi, my name is Dr. Ahmath. In this video lecture, we are going to discuss about the statistics. This is going to be the first video in our series of the lectures about the statistics, and today we are going to discuss what is the statistics. So one of the good definitions of the statistics was given by the former Prime Minister of the Great Britain, Benjamin Disraeli, who said that there are three types of the lie: just the lie, damned lie, and the statistics. So by these words, I just would like to mention that statistics is a great tool which can bring you for the true conclusions about your data, but at the same time, it is very easy to manipulate with the opinion of the society by just using the statistics. So knowing statistical methods and knowing how to make the conclusions from the statistical methods, from the data using the statistical methods, will help you always to identify those wrong conclusions. So what is statistics? So statistics is, first of all, the science about the data. The data is the collection of the observations, such as measurements, gender survey, or the survey results. For example, you may measure the height of people in the streets, or you may be wanted to know the opinions of people about some or the other type of the questions, or you would be interested to know the gender of the students in your university. So this whole collection of the measurements is called the data, and the data is a plural form of the word, and in the singular word is called the datum. Well, statistics is the science about the data, and now let's learn what is exactly the statistic or statistical methods, tools are. Statistics is first of all about the collection of the data. So we can collect the data and we can store them in some arrays or in some tables. For example, this table here consists of the grades of the 60 students. So for example, the first student has got 8, the second student has got 14, 18, and so on. So you can just store them inside this kind of table. But statistics is not only about storing the data, it can store the data and it can summarize the data and store the data in a very compact form. So what we can do is we can just create another table, which we are going to call as a frequency table, and we can store the whole bunch of these big tables in the smaller tables by just creating the classes and by just counting the number of the data points which corresponds to each of the class. So for example, here we create the first class, which is 1 to 15. It means that all of the grades in between 1 and 15. For example, I can go through all of the grades in the table, for example, 8 or 14 or 10 and so on, and I can count the number of the items which is inside this class between 1 and 15. Then I can choose the second class, for example, 16 and 30. Then I can go through all of the data points again, and I can count the number of the items, which basically is going to be contained in the second class. For example, 26 is there. Then 31 to the 45, or 46 to the 60. Then I can count the number of the items which is consisted in each of these classes. So this type of the graph, or this type of the table, is called the frequency table, and this is one of the tables which allows us to summarize the data in a very compact form. So the huge amount of data tables with millions of the entries can be summarized in small tables. It is very easy to see some consequences of the data. But most of the time, it is very difficult to see very good features or important features of the data from the tables. So that is why we're going to use the graphs in order to understand the features of the graphs. For example, this is the type of the graph which is called like a bar chart. So in this course, we're going to learn what type of the graphs we can use, the different type of the graphs we can use in the different scenarios and the different situations. At the same time, the graphs can be used in order to interpret the data, in order to assist to make more efficient decisions. So first of all, I need to mention that no matter what your profession is going to be, you need to make decisions in your life. And making the decisions and statistics is going to help you to make those decisions correctly. And the graphs are going to assist us to make those decisions efficiently and correctly. So we're going to learn about the type of the graphs. So this type of the graph, for example, is called a scatter plot. The previous one is called a bar chart. You see, so for the depending on the different purposes and different data types, we're going to use the different graph types. So we're going to learn about all types of the graphs, and it is important for us to choose a proper graph to get a maximum amount of the information, or to show the maximum amount of the information from the huge data collections. So when the statistics, so this part of the statistic, which is about collecting and summarizing, presenting the data using the tables, or interpreting the data using the tables, is called the descriptive statistics. But at the same time, it appears there is another type of statistics, which is called the inferential statistics. So inferential statistics is about making conclusions about the whole population by just drawing some numerical values from the samples. For example, I would be interested to know what is the proportion of the males in the whole Earth. Or for example, what would be the number of the children in the different countries, or the number of the energy consumes of people in the countries. So what I can do is, or what is the height of people in the whole Earth, right? So what is the height of all of the males in the Earth? So usually it is difficult to answer to this kind of questions because it is infeasible and often impossible to measure those things, right? So it is impossible to measure the height of all of the people on the Earth. And what we can do is we can just create samples. We can just take a small number of the people from the different locations, and then we can measure their heights. And then by just finding the average height of those samples, we can draw the conclusions about the height of all of the people. For example, you would be interested to know what is the average grade of all of the students in the university, right? Or average GPA, for example. Then you don't need to go through all of the students. What you can do is you can just choose a small sample, and then you can just find the average of those samples, then draw the population's mean, right? The mean of all of the students' grade, by just finding the mean of the samples, the grades. Or the same as you would be interested to know what is the average IQ score of all of the students in your particular university. Then in this case, again, you can choose some samples, then you can just find the mean IQ score of those samples and draw the conclusion about the IQ score, the average IQ score of all of the students in that particular university. Well, I'm talking about all of these things. So this part of the statistics, when we are going to draw the conclusion about the whole population from the sample, is called the inferential statistics. So we are going to talk about the two different types of the statistics. One is called the descriptive statistics, and we're going to learn about the methods of summarizing and collecting data and graphing the data. And inferential statistics is when we are going to create the conclusions about the population's parameters using the statistical numbers. So it's statistical numbers taken from the samples. Well, this is important for us to know what is the population in the sample, first of all, right? So the population is all items which are considered in a given context. So this is the complete collection of all of the measurements, all the data that being considered in the given context. And the sample is sub-collection of the set. So we're going to choose some items from the population, and that's going to be our sample. Or for example, all of the sheep in your farm is going to be the population. And if you choose 2 of them, it is going to be a sample, right? So if you would like to know what is the average weight of all of your sheep, so you might have like 1,000 of the sheep, it is very difficult to know this, right? So because you start measuring one sheep, then until you measure the thousands of them, so the weight might be changed, and it is very difficult to know the average weight of sheep in your farm. So what you can do is you can just choose a samples by just choosing 2 of them, or like 5 of them, or 10 of them, and then just measure their weights, find the average, and draw the conclusion about the weight of all of the sheep in your farm by just finding the mean weight of the sheep from your sample. So again, the population is the all collections of the data which being considered, and the sample is some portion of this. It is some collection of this. Okay, so this is going to be the sample. Well, it is very important, it appears, to know how to choose the sample. So let me give you another example of the population in the sample. For example, do you worry about the identity theft, that your data about your identity can be stolen? So this kind of survey was made in USA with the population of more than 328 millions. And Gallop poll surveyed 1,013 people, US adults, and 66% of the respondents worried about their identity theft. So the Gallop poll makes the conclusion that roughly 66% of the population of the USA are worried about this. So you see, so we can't really just ask all of the persons, all of the people in the whole country, but we can just take a small sample. So there are 328 millions citizens, right? Then you can choose a small sample of only 1,013 people and just ask them about this question, and by finding in this case, the proportion, it is going to be 0.66, right? So by just knowing the value of the sample, we are going to create the conclusion about the whole population. And the question is always how to choose the sample. Is it important how we are choosing the sample, or we can just choose the sample randomly or as we wish? Well, it appears there are different methods of choosing the samples. So we are going to classify them into the 4 different types, or 4 popular types. So most of the time we're going to use one of the 4 methods of choosing the samples. Again, so you've got a population with lots of different data, and now we need to choose some of them to include to your sample. And we are going to see through this lecture that it is very important, it appears, how exactly we're choosing these data points in order to create the samples. So the first method is simply randomly selection. So again, so you've got the population, and in order to create the sample, you're going to choose them randomly. Okay, so at any order. So for example, here I'm going to choose 3 persons from a population randomly, and this is called a simple random selection. So there is another method of the sampling. It is called the stratified sampling. Again, the sampling method is how we are going to choose or create the sample. So stratified sampling is when we are going to divide the population into the groups, which are called the stratas, and then we're going to choose people from each of the stratas. Again, so we are going to divide the whole population into the stratas, like this. Okay, so depending on some of the categories, we are going to divide the population into the stratas, into the different groups. And then we are going to choose representatives from each of the stratas. Okay, so most of the time I would say that this method of sampling is very good, is considered very good. For example, in this case, your sample is going to include the representatives from all of the different groups of the population. So another type of the sampling is called a cluster sampling, when we are going to again divide the population into the stratas. But if you remember, in the stratified method of sampling, we choose the persons, or we choose the items from all of the stratas. In the cluster sampling, we are going to choose some of the clusters randomly, and then we are going to some of the stratas randomly, some of the groups randomly, then we are going to choose some of the items randomly from each of the stratas chosen. So this is a little bit sophisticated method of the sampling, more than sophisticated than the simple stratified sampling. Again, so we're going to simply divide the population into the groups called stratas. Then we're going to choose some of the stratas randomly, not all of them, some of them. And then we're going to choose people from those stratas randomly. So the last way of the sampling method, which I wanted to discuss with you, is called the systematic sampling, when we are going to choose members or the items from the population depending on some equations or the relationship. For example, you would be interested to choose every 3rd member from the population. So in this case, or every 5th one, or according to so-called Fibonacci sequence. the items from the population can be chosen in order to create the samples. Well, these four methods are very popular in order to create the samples, and you can see throughout a couple of the examples which we're going to consider today that the sampling method is superbly important. So I would like to give you a small example of the sampling methods. For example, you would be interested to know how the mobile data is used in Uzbekistan. Right? In average, for example, in average, how many megabytes every consumer uses, or how many gigabytes every consumer uses in average per month. Okay, so this is especially important for the mobile operators in a country in order to create the new plans, right, and the prices. So you can choose your sample. So of course, you cannot really measure, or you cannot like count the mobile data usage for all of the customers in a whole country. You can create samples, and you can create the samples differently. For example, you can create the samples by the clustering sampling. So in this case, we are going to divide the customers by their geographic location, by the cities, for example. I'm going to create the 12 different stratas by the living places of the 12 of the customers in the 12 different cities. And then I'm going to choose 3 of the cities at random. For example, Tashkent, Samarkand, and Fergana. So there are 3 cities in Uzbekistan. And then I'm going to choose some of the customers from those cities at random in order to create the sample. And at the same time, I can do this by the stratifying method. In this case, I'm going to split the whole customers into their geographic location, into their cities, and then I'm going to choose the customers from all of the regions, all of the cities in my samples. In this case, this method of the sampling is called the stratified sampling. Or I can create stratas by the financial position of the customers, or by their ages, or by their wages, or by the other different type of the categories. Well, I'm going to give you a small 2 examples, which are very good, popular, and illustrate how important it is to choose a good sampling method. So they founded in 1980s, or I would say 1880s. So there's a typo, definitely. Founded in 1880s, the Literary Digest magazine was famous for its successful prediction of the presidential elections in 1916, 1920, 1924, 28, and 32 in USA. In the presidential elections in 1936 between Alf Landon, he was Republican, and Franklin Roosevelt, he was the Democrat, the magazine sent out 10 million ballots to their customers, and they've received 1.3 million of ballots which support Landon, and only 0.97 million ballots which would support Roosevelt. At the same time, a small company created by Gallop poll, by George Gallop, they've surveyed only 50,000 subjects, and they predicted the results of the presidential elections correctly. And the result of the presidential elections was roughly like this, like a 36% for Alf Landon, who was Republican, and 60% roughly for the Roosevelt, who is Democrat. So this example shows you that the sample size is often not the first priority of the importance, even though the Literary Digest magazine sent out 10 million magazines and 10 million surveys, right? And they received the millions of the results which would support the Alf Landon. And at the same time, George Gallop sent only 50,000. He predicted the results correctly because he chose the sample correctly when he's included the people from different categories into its sample. At the same time, the problem with the Literary Digest was that most of the people who read their magazines were the Republicans, or the people who would support the Republicans, and it was like they send and it was kind of predictable that they are going to send their support or their votes for the Alf Landons. In this case, the problem with the Literary Digest is that the sample didn't include enough people from the different categories or different stratas. So this is one of the really good examples which shows how important it is to create a sample, or the sampling method is. So another method or another example why the sampling method is important is the following. During World War II, the British Army decided to add more and more to their bombers. So what they did is they created the map of the bombers which they came back from the fights. So this is the typical map of the bombers which came back from the fights, where the black areas is denoted the number of the holes. So if the number of the holes concentrated more in those areas, they are going to be denoted as the black one. And the white areas here are denoted the areas where there are no holes at all. And experts actually thought that it is necessary to add more and more to the places with more holes, and this decision was considered as logical way. So they are going to include more and more to the places with more holes, and in order to increase the efficiency of the bombers. And again, the problem is always you can't really add amors infinitely many, right? So you cannot add more for all of the parts of the planes, because it is becoming more heavy, that it is going to use it is not going to be efficiency enough. So at the same time, British mathematician Abraham Wall suggested to reinforce the spots that didn't have bullet holes at all. So they decided to include more and more to the places without the bullet holes at all. And it helped to increase the efficiency of their bombers. And the logic behind of this is that the sample, which includes the British Army, was only the bombers which came back, right? So they included, they drew this picture of the typical bomber which came back. And at the same time, the sample did not include the bombers which didn't came back. And the idea was of the Abraham Wall was that, hey, so the planes which are not coming back is because exactly they have the holes here. And it was a really good decision, and it helped a lot to increase the efficiency of the bombers of the British Army. So these two examples illustrate how important the sampling method is. Well, in our next lectures, we're going to discuss about the types of the graphs and the other type of the statistical methods. Thank you very much for your attention. I hope that this was interesting and helpful for you.